Let's start studying the traffic analysis by Infraworks. I have downloaded this area from Model Builder, which already crowded and full of buildings, in order to study the real simulation of the traffic at this location. So I already made a point of interest in somewhere here to study this location. Okay. I have some major routes at this direction and some minor routes at this direction. Have this, you can consider this major collector, and this is minor collector, and some local routes in between. I'm going to analyze the intersection of traffic for this area by Infraworks 360. But first step, to convert this route from conceptual route to be component route. So once you select this, right click and convert this route, you have the ability to do the analysis on this route. If you're still working on conceptual design, so you don't have the ability to make the analysis. Okay, so after preparing my studying area and converting all this route to be component route or design routes, now I'm ready to make the analysis. I'm going to zoom in at this area, and I'm going to routes and analyze. Okay, and do traffic simulation. In this case, he will ask me to publish my model. If you want to publish the model, just click on publishing model. He will ask you about the destination for your account in BIM 360. I'm going to select the place, maybe my project or simple project, whatever the publish location, and then publish. Okay, let's select sample project, publish. So the Infraworks started to publish the model on the server for BIM 360 in order to make the analysis of traffic. After publishing our model, let's go for our point of interest for our area. Here is our area to study. Okay, let's go for traffic simulation again, then select our area of interest, including this one, this intersection, and this one, and this one, and this one. Create, enter. Now I already created the boundary of my traffic simulation. Are you going to transfer all planning roads inside this area to be a component road? Yes, I am going to convert all to be component road. Start converting the internal routes, which already local routes, to be component route. Now Infraworks finished already creating the conceptual design or conceptual routes to be component route. Let's start first task in study analysis. First, I'm going to make quick simulation for the existing condition, and then I'm going to evaluate the existing condition and put my proposals. Okay, first I'm going to make quick simulation in the morning, and I will go for run simulation, and let's see what will happen. It will take 1 credit required for this simulation, and each time of preparing traffic analysis, it will take 1 point from your credit. Okay, this point called the intersection coming points. So this point can control the number of cars go inside and outside this area. So at this area, demand in inside this area is 11, while the demand out is 0. I think for this road is one direction, that's why it's in 11 and 0 out. For this area, we have 0 in and 9 out. Okay, for this one, we have 10 in and 7 out. This demand is depend on the traffic observation which done on the site, whether manual or using some instruments. Okay, so here 11.0, here 9.14. Okay, and let's make our simulation. If I click play, I'm going to start seeing our car by my speed multiplied by 10. If I go for the normal speed, here is a car, make the left turn, and one car is waiting for the signal. And if you want to increase the speed, you will see faster this car waiting for the direction of measure, and this car is waiting. Okay, then let's go for right turn. Now this car is waiting and this direction will go. Okay, so it seems reasonable to this demand and maybe it's okay, but I'm going to test this connection for the worst case scenario based on additional demand, and let's test our junction at this location. Okay, how can I start modifying my data for transportation or for traffic in this session? I'm going to close my animation and I'm going to click here and right click and select traffic analysis panel. Traffic analysis panel is going to give me the control for each element of traffic during my analysis. So let's start explore the traffic analysis. Here is my traffic analysis interface model. I have 3D model for the same area of study. Okay, and I have 1, 2, 3, 4, 5, 6 intersection. Okay, my quick simulation done at AM morning, and duration of this simulation is 10 minutes only. Okay, so it's fast simulation or short simulation. I have the option to go for short morning 60 minutes and long morning 180 minutes and short evening 60 minutes, long evening 180 minutes. Okay, I'm going to use the quick simulation to just deliver the idea. Okay, so this is AM mean morning and 10 is the number or minutes duration. Okay, I'm going to explore what is the main feature of the Infraworks traffic analysis. For the parameters, I'm going to explore the terms. Terms, here is our always and simulation. Our simulation, current simulation is 10 minutes only from 8 up to 8.10 or 8.10. Okay, this is first assumption. The second one, restriction. Maybe I have some restriction from this area up to this area. There is no traffic or there is some kind of restriction for this one. Also, I can control the speed. This is my design speed and this is my speed used. So I can change my speed from 30 to be 30-25 or 40 to be 30. So there is a design speed and operational speed. I can control my speed from here. Okay, after you control or modify, just select OK and close. Let's go for the type of vehicles. I have many types of vehicles stored on the library of Infraworks. This is a small car. Description is small car. Size is 4 meter. Width 1.7. Height 1.45. And this is the weight and so on. Dynamics, tire friction, attachment, and this is the criteria of each truck. I'll go for control intersection or boom gates or ramp metering or timing playback. Boom gates is like a gate with control for one steel rod, can be up and down to control the gate. And ramp metering is one traffic signal on the ramp. Here is the traffic on ramp meter. Here is the traffic metering, here is the ramp, and here is my ramp metering at the end of the ramp, controlling the traffic from the ramp towards the main line. This is the boom gate. Okay, so let's go for our Infraworks controlling. This is the boom gates. We understand what is the meaning of boom gates. And this is demons control. This is ramp metering, and we understood already what is the mean metering. And time playback, if you need to make some delay in time and control the playback for the signal, you can control from here. Okay, and if you want to control the intersection, just select intersection. Okay, we will come back for this one, but first we are going to the demand. Going back for the demand, I'm going to select demand and demands. If you select each one of those, it will give you the direction of traffic coming from this area to 1, 2, 3, 4, 5 area. So the traffic coming from this point divided up 3, 3, 3, 3. The total of this one is the outlet from this point. Okay, if you select this one, so from this point I'm going to one direction, 2, 3, 4 and 5 and so on. So this is controlling the demand for each control point of the study. If you select this one, so it will give you only the individual direction from this point up to this point. Okay, and if you select this one from here to here, this one from here to here, from here to here, and so on. So this is based on this volumes is based on the traffic demand done on the site. I'm going to test my intersection by increasing the demand to be 200. I have only 60 here maximum, so I'm going to increase this number to be 200 and check our capacity for each intersection will work or not. I'm going to select OK, and I'm going to control my intersection. Let's take one by one. If I select this one, first intersection, I have intersection 3, 4, 5, 8, 10, and so on. If you select intersection number 3, you have the movement from here to here. This movement should be yield, and this movement should be open, free flow. This one should be yield. This direction should be free flow for the main road, and this direction should be free flow, and this direction should be stop sign. Okay, and the other one from here to here, stop sign. From here to here, yield. from here to here, stop sign, stop sign, stop sign, and the last one, yield. So by changing this number of yielding and number of controls, I can manage my traffic study during the intersection. Okay, so based on what we studied before, the type of movement, whatever yield or whatever straight, who's going to respect who. This is the main route, so I'm going to be freeway here, and I'm going to stop at this condition. So let's make the worst case scenario. I have the stop case for each one. Okay, so I'm going to, even for this one, for the main road, I'm going to select for stop sign and stop sign. Let's say okay, and this is our intersection number 3. If you move for the other intersection, from control intersection number 4, okay, this one, I'm going to keep this as it is to see the difference between our proposal and the second proposal. Okay, I'm going to close this menu and back for our Infraworks. Let's make another simulation and check what happened. Okay, here we finished. Let's go for our new simulation based on the new demand. I'm going to make play, and let's see the difference between this intersection and this intersection. As you see, the waiting time for this intersection is higher than this one, because this intersection has a lot of traffic and not organized like this intersection. So I'm going to change the intersection at this area to be another type of intersection based on the traffic study which I did already. Okay, as you see, traffic volume here, I have a problem with waiting, but here it's working okay. Another intersection, I have a lot of storage lanes here because I have only one lane, so I need to increase, maybe increase another lane here to increase the capacity of intersection. Okay, again run another simulation. Here we have waiting, here it's working okay. Okay, so let's start changing the configuration of this intersection. I'm going to close this and close this and come back for Infraworks again. Due to the heavy demand in this area and due to the configuration of this intersection, I'm going to change this to be another type of intersection. I'm going to select the intersection and go here and select roundabout. Once I selected the roundabout intersection, let's go for the default one with 2-lane intersection. By the first look, I already make some encroachment with existing building which already is not accepted as per study. So I'm going to change this type of intersection to be the smaller one. So from here I can select this one to be 2-lane, double lane, spiral marking, and check the size. Okay, then I can go for the internal radius and reduce my radius, squeeze a little up to avoiding the building demolition. Okay, let's see what happened. Okay, here is my new roundabout. I can move even this center to go away from this south corner, and let's check what happened. Okay, I think now I finished already. Based on the existing condition, I have avoided the demolition at this area. Okay, I'm going to make another simulation for this area and check what will happen. I come back for traffic simulation, and this time I can go for Berlin and run simulation. It will take also 1 point of credit. Okay, let's make our simulation animation. Okay, let's make play. Here's our existing situation right now. I don't have any problem. I have rectified this intersection from this heavy traffic to the smooth one based on this roundabout. Okay, now I don't have any delay at this area. Even my queuing storage length or storage time is 50 seconds, which is already acceptable comparing with the delay threshold, and even the queuing length is 81, which already accepted. Here there is no queuing, there is no queuing, and here is also I solved this average delay reduced, while this one still have a lot of waiting time up to 128 seconds, and I have 114 seconds, which actually not accepted at this kind of intersection for waiting and wasting of time, which already will reduce the level of service based on the customer satisfaction. Okay, so if you want to reduce these errors, just go and change the intersections of intersection type of this junction in order to accommodate another type of traffic. Okay, so by this way we have the ability to study our existing demands and our future demands based on the site observation and the future studies.